What's going on, guys? Today we are covering Zero Logon. So, this is actually a box I'm pretty excited for. I really like the boxes that are proof of concepts that you actually get to physically do a real attack that happened. And that's one of these. So, this one is called Zero Logon. It's a little old as far as CVEs go. You can see it's 2020, but we're still going to cover it. And it still kind of shows you these 0-day attacks, how complex they can be. This one's pretty simple, but it's very hard to have found this without understanding things fully. You're not just going to have Joe Schmo off the road figure this one out. So that's the cool thing. So this one here, Zero Logon, if you guys don't remember this one, basically it's purely statistics based, meaning that someone found a mathematical anomaly, basically, that takes advantage of a cryptographic algorithm. So that's a lot of words to say. You can see here, Microsoft chose to use AES CFB8 for a function called compute net logon credentials, which is normally fine, except, here you go, they messed up. They hard-coded the initialization vector to all zeros. What does that mean? So the way cryptography works, guys, if you aren't familiar, if you just released cryptographic algorithms and it was just like, okay, you take this word and you times it by this and move on, whatever, it would get cracked so easily. So what they do is they are supposed to have initialization vector, which is it takes the algorithm and it puts a number right before it and either multiplies it, it either binarily changes it. Something, that initialization vector is supposed to change for each freaking hash that it's going to do, right? And it didn't change. It always stayed zeros. So therefore, it's predictable. Okay? So this attacker figured this out. He figured out that they hard-coded the zeros in there. So what does that mean? Well, you guys all understand basic math, right? 0 times anything equals 0. So eventually, the algorithm's going to mess up because it's going to use those zeros in a multiplication. And when it does that, the message only containing zeros, there's a 1 in 256% chance that the ciphertext will be 0. So eventually, that equation will equal 0 if done enough times, because eventually that initialization vector is going to be placed in a location to make it 0. Now, if you guys have seen cryptographic algorithms, they're pretty complex, so it's above my math level to, like, I don't even know if anybody can actually physically do the math. I'm sure they could if they had enough time, but I can't. So I understand how it works, and I'm certified in cryptography, but I can't sit down and do that math. So just understand that 0 times anything is 0. So eventually, if you try it enough times, it's going to equal 0. All right. So now about machine accounts. Okay, so now basically what this did, this gave us a 1 in 256 chance that the ciphertext will be 0. So therefore, we can guess it, right? Which is a problem when you're doing cryptography. So normally if we tried a statistics-based attack, we'd get locked out. Pretty well known that if you try your account, 3 times in most places or 5 times, it's going to lock it out. Well, machine accounts are different. Why? Because machine accounts, if you lock them out, you're kind of screwed, because they're local machine accounts. They're not the same as network accounts. So if you lock it out and then you disconnect that from the domain, you have no way in. So machine accounts usually don't lock out, and that's pretty common. They have no predefined account lockout attempts because a 64-plus character alphanumeric password is normally used. Yes. So what happens is these machine local accounts are tied to the machine, not to the domain. You can't use them to log on to any other machine, and therefore they're usually secured pretty tight, but they usually don't have lockout procedures. That's why they're secured pretty tight. So, so it's not meant to be accessed by any user. It's just usually a backup account. It's for something, last-ditch effort, it's disconnected from the domain, you need to get in. Okay. So, yep, you can use tools like Mimikatz to dump these, but that means you've already compromised the machine because you're running Mimikatz off, so you had to get Mimikatz on the machine, which means you probably already took it over, so it's not really that useful at that point. Especially if you take over a machine's admin account, like people think like, oh, I got the admin account. Yes, you do, but that's just for that machine. so it's not really useful network wide. So it's kind of pointless to, not pointless to get it, but in a sense, if you're trying to take over a network, it's not going to help you. It's just going to help you with that one machine. So, okay. So machines often hold system level privileges, so they're admin accounts typically. If you're not familiar with Active Directory, we can take the domain controller's machine account. So that's the big one, is there's a difference because we're now taking over the machine account for a domain controller. Well, domain controller controls the entire domain. So if we have admin access on the domain controller, that's different than just a regular local machine. So we can use the machines account to grant authentication in conjunction with secrets. Secret dump is a password dumping utility. So secrets dump, it's just a tool similar to Mimikatz. It'll dump the password hashes for you. The only difference is it runs from your machine. You don't have to put it onto their machine and run it. You can run it from your machine and run it to them. All right. So zero login to bypass authentication. So what are we going to do? Here's the general thing we're going to do. So authentication to domain controller's machine account. We're going to run secrets.dump to dump the credentials. We're going to get the admin hash. Now we can do a couple things with it. We can pass the hash, which is an attack we're going to do today. We're not going to crack it. Or you could take it offline and crack it and crack all the hashes, which you would normally do. And, if you're doing a pen test or something and you get 50 hashes, you're going to try and break them regardless if you can pass them and get in, because the customer needs to know that too. They need to understand that even if they could fix the pass the hash attack, they still can crack their hashes pretty easily. So, okay. At this point, we know a vulnerability exists, but we're not sure how to exploit it. So we're going to look at the handshake. So this is the basic concepts of what's going to happen. So this is how it's going to normally look, that login authentication handshake. Client, server, they get a session key, client credential, server credential, and then boom, you have a actual session. Now here's how it's going to look the way we're going to do it. They're going to send the challenge, but you notice we're going to purposely put all zeros in there. Well, the reason is mathematically, since we know that the initialization vector is 0, if we make the challenge be 0 as well, it's a 1 in 256 chance that the actual password will equal 0 when it's done. Now, they're going to give us a script, and we're going to go through that script, and we're going to then use that script to test, to just say, yep, it works. It's a test script, and it's a good test script because this is a little old, so you probably already are patched way past this if you are, using a domain controller. But it's a good script that you can go and run on your domain controller, and it'll just say, yep, it's vulnerable, or no, it's not. It'll run it. Basically, what it'll do is it'll run the script the for loop 2,000 times, and if it doesn't get to 0 in 2,000 times, then it's not vulnerable. It's saying that statistically, it would be very unlikely that it didn't get it in 2,000 tries. So, okay. So the client creates a net server challenge request, sends it off. That's what we just covered. The server receives that request, will then generate its own nonce. This is the server challenge. The server will send the server challenge back. Okay, the client, us, will then compute its logon credentials with the server challenge and use this protocol method, which requires the parameters. So this is important because this is what we're going to need to use. So there's different parameters that it's looking for. So a custom binding handle, an account name, a secure channel type, computer name, client credential string, and negotiation flags. Now we're going to cover these a little bit more here down below, so don't worry about it. But you can see a lot of this is very basic information. The account name could be admin or whatever. Here they're saying it's DC01. The computer name, DC01, domain controller 1. And then this one, a secure channel type. InPacket, which is what we're going to cover here, handles this for you, but this is what you need. If you didn't have InPacket, which is what we're going to use, you would have to specify the channel type. Okay, so if the server calculates the same value, the client will re-verify, and then mutual agreement is confirmed, which will then begin the session. The session key will be used to encrypt communications between the client and server. So what does that mean? It means now the traffic is encrypted, but you have the session key because you generated that session. Okay, so InPacket installation. So I'm going to show you guys. I do have us here, and you notice I do have in packet environment. This is the attack box. I do recommend the attack box because it says it right here. In packet can be quite fussy. So you guys have seen my BYOB video. I'd say weekly, I get multiple people coming into the Discord and stuff saying, hey, BYOB didn't work, whatever. Same thing, it's fussy, meaning it needs very, very specific that, everything needs to be perfect for it to run properly. And the attack box was built so that it runs properly. So on the attack box, I still ran these steps, and then it'll get you in this in packet environment. You can see here, you need to run them. I'm telling you, if you don't run them, you're going to be kind of struggling for a long time. I don't even know if you can. There's other ways to complete the same proof of concept, but I don't know if you could do this lab without running them. So just run them. Make sure you do that. All right. So proof of concepts are incredibly important. So again, this is very true. It's incredibly important because if you didn't have proof of concepts, basically if you didn't have people that come out and say, hey, you can do this step by step and it will work, then you're basically saying everything's theoretical. The problem with that is computers are finicky. You don't know just because you say, hey, I found this vulnerability because mathematically it makes sense. You don't know if the machine's going to act the same way, and you don't know if the machine's going to accept what you're telling it. So proof of concept is necessary in order to prove the concept, obviously. Okay, so before we continue any further, you should download the POC from Secure, which can be found here. And you can see here, I have the zerologin.py right here, and that's what we're going to use to actually prove this. So we're going to break it down. I'm not going to go through every little detail. I'm just going to kind of explain it to you guys. You guys can read it. It's a fairly short script, but it's still important to understand how it's working. So the first lines, you can see they're importing everything you need. And then here they set that variable. That's a global variable, meaning it doesn't change throughout the script at all. That's why it's all caps. And the variable is 2,000. So again, max attempts is going to be 2,000. It's a 1 in 256 chance. So if you run it 2,000 times and you don't get it, the chances are most likely that it's patched. So that's why they chose 2,000. You could up that to 10,000 if you're not sure or whatever. But 1 in 256, you'd have to have unbelievable odds to miss that. Okay, so here you can see they're actually starting to declare stuff. They're printing, so they're telling you what's going on in the background as you're doing this. It's using the same variables that you're going to declare earlier. All right, so, and then perform attack. Okay, so nothing crazy there. And I'm not really sure why they did this. They kind of break it into weird. So like this is line 76 through 86, and then 57 through 73. I don't know why they don't have it in order, but it doesn't really matter as long as you understand it. So you can see here, they're skipping to the bottom. So they're skipping to the bottom so that some variables later will make sense. Line 1 is essentially declaring a main function. Yep, it's declaring the main function. Yep, line 2 is checking. It's an if. If it's not equal or less than 3, blah, blah, blah. Okay, you guys can read through that. It's a pretty simple script. I'm not going to run through it too deep because you guys can read this. It's pointless for me to just read it to you. Let's see. Okay, so if it works, you can see it's going to print success. The domain controller can be fully compromised. If not, it's going to say attack failed. The target is probably patched. So again, the key emphasis is probably because, again, it's all math. Eventually, if you run this enough times on domain controllers, it's very, very, very high odds, but eventually it could miss one. All right. So you can see here for attempt in range. So it's running a for loop. It's going to start 0 and it's going to go to max attempts, which we saw earlier is actually declared at 2,000. So it's going to run a for loop 2,000 times until it gets the 0, which is what we're looking for. Okay. So here they're defining try 0 authenticate, and you can see they're passing some arguments to it, the DC handle, the IP, and the target computer. Boom, boom, boom. Okay. You can see here they're establishing the plaintext and ciphertext variables, which they're being set at 0. So That's fine. Line 4 contains a variable called flags. Right there, flags. These are the default flags served for Windows client. So these are the flags that you saw earlier that it's requiring. It's setting them for us. Line 6 is where the fun begins. So this is line 6. And you can see this is where the step 1 and being in figure 1. The client creates a net server challenge request requiring the following documentation. So this is where it's going to start asking you for the computer or for the information, which you can see they put right here in line 8. Server auth equals target computer. So all these variables are set earlier, and then it's passing all those variables to it. And if you remember, we required those variables right here. Those variables are, where are they at? Right here. So these are what they're going to require. They're going to require the primary name, the account name, secure channel type, computer name, authenticator, and the clear new password. So you can actually change that if you know what you're doing. You can actually make it whatever password you want and then change it. Or you could just set it all at zeros and leave the password empty, which would then give you a null password or blank password. Okay, so these are required. We have most of them. Excuse me. And you can see here, if we're going to actually look at this documentation, which is right here, and you can see this is what they need. They need the primary name, account name, secure channel, computer name, and this is all based on Microsoft documentation. So this was all public information that you can find. Okay, so now per the documentation, net login credential can take 8 bytes of data. The second bullet point outlines the data field carries 8 bytes of encrypted data, blah, 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 blah. Fortunately, we know this value. Why do we know this value? Because zero login sets it to 0. So we know it's going to be, if it works, it's going to be 0, which is what we're checking for. We're checking for if that equals what we think it should equal, which is 1 in 256 chance it's going to equal 0. So if we try it enough times, it will equal 0 when we run it. Okay, so for the simplicity of this room, so this is where they're talking about the password. So this is how Microsoft runs their passwords, right? The net login password consists of 512 bytes of random padding. So it's random minus the length of the password. So whatever junk you want to put in, just padding plus password with the last 4 bytes I don't know what I'm saying. The length of the password totaling 516 bytes. So what you can do is you could put junk in the password, and then if you do the math, it's pretty easy. However much you want, then your password, and then you should be able to get it, right? But if you don't want to do that, you can and for simplicity of this room, you can simply supply 516 bytes of all zeros, and then it makes a null password, makes nothing. So the password would just be nothing, which is the same. It's fine. There's nothing wrong with that. At least if you're attacking something, there's something wrong with that if that's your password in real life. Okay, so now that we know we required arguments to change to blah, 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 you can see, again, they're giving you the same arguments. As expected, most of the field names are what Microsoft provided, which is what we said, except for some differences. So you can see they've changed a little bit. You can see here on the authentication portion, you actually need a couple of things here. You just need the credential, timestamp, whatever. So they're just kind of breaking down for you what is required if you were going to do this yourself. But they do give you the code here because the initial script that was up at the top doesn't have this additional information in because it doesn't know what Microsoft requires, the script when it was created. So you'd go here, you'd copy this, and you'd fill in whatever you needed, and then you would insert that code right here, okay, into the script. And they tell you how to do it, but they also give you the script finalized, so there's no reason to do that, really, in my opinion. Okay, so at this point, your code should be good to go, and you should be able to successfully exploit the zero login. Okay, so here's where we can successfully exploit the zero login. So you can see I have the zero login.py. Now, it's a Python script, so we got to run Python 3, zero login.py, and then I don't even know if you need the DCO one. I'm just going to show you guys this. We are going to scan it first, but I'm looking for the IP. There it is, 1010. 89. And if you hit enter, you can see it only took 35 times and it was successfully exploited, and it changed the password to nothing. So now we could just log right in, right? Now, what you would do first before doing this is you would set in-map it. Now, I'm not going to sit here and make you guys in-map it. Here's the in-map scan, the results. So in-map, SCSV, 1010, blah, blah, blah. Now, this is where it's going to start asking for these questions here. Now, you can see what method will allow us to change the passwords over in our PC, and that's this one here, netserve password set 2, netserve password set 2. That's the method we're using. What are the required fields? And again, primary name, account name, secure channel type, computer name, authenticator, return authenticator, and clear new password. Those are all need to be put in there. What op number is the method? Op number 30. Boom. And then modify the POC. So now go ahead and modify it. Now we're in the lab. Now we get to have some fun. So we already modified it because it's right here, modified. You don't have to actually go in and put your code. They give it to you. So we have the modified. Now let's lab it up. Okay, so Control Z. After you get done, if you want to play around some more, instead of terminating the machine, you can simply issue the following command to reset the machine back to its original state. Okay, I didn't do that. I'll just let you know. So we'll see what happens. But it should work. Okay, so you can see here's the initial in-map scan. It's asking us, what is the NetBIOS name of the domain controller? NetBIOS name. Where is it? I saw her. So you can see NetBIOS name DC01. Perfect. What is the NetBIOS domain? That's right here. HoloLive. That's the domain name. And then what's the domain? The actual domain? hololive.local. That's the actual domain. So it's the way you read this. DC01 is the domain controller 1 on hololive.local. That's the domain that we're attacking. Now, what is the local admin's NTLM hash? Okay, so we can go ahead and minimize that. So now we installed Mpacket. So we go into Mpacket, and you can see there's binaries in there. And you can see the secret dump.py. So we're going to go ahead and run that secret. I think I've got it actually in my history, so we don't have to do it, get all crazy. Okay, so you can see right here, secret stump.py. And we used a couple of flags here, just DC, so we just want the domain controller, and no pass. You need to use those. You can actually just run secret stump and look at the help menu and see why. It's pretty self-explanatory. And then you need to do it in this format. DC01 is the actual NetBIOS name that we're looking at. And then the $@ for 10.10.52, whatever your IP address is. We hit enter. You can see we get all this. That's awesome. So we got the admin, there it is. Admin here, the local NTLM hash right there. So there's the local NTLM hash. So that's what they're asking for. And that's for the local admin account. Now, how many domain admin accounts are there? This is just a guess. I'll tell you guys now, I don't like the way they worded that because this is not how a lot of places are going to necessarily do it. But you can see here, there's different accounts. There's only 2 with an A in front of it. That probably stands for admin. So there's 2. Now, that's a guess based on their format. Just because, based off this screen, just because that has an A on it, doesn't necessarily mean it's an admin. We're guessing. We're assuming it is. But if you go attack or pen test a regular enterprise company, they may not have that. They may not have any indication on this screen that it's a local admin account. So, or a domain admin account, excuse me. So I just wish they would have clarified that because this isn't how, you're not going to always pull it up and be like, oh, admin. So just keep that in mind. All right, so now what is the root flag? So you can see we've already got the NTLM hash. So now we're going to try to pass the hash. And that's what this is for right here. So we'll go ahead. I'll clear this out. And I know I've got it up here. There it is. Okay, so it's the same evil win RM. TAC U for user, administrator. And then the local admin hash, tac H for hash. That's the same hash that we just saw on there. And then I is the machine IP address. So if we hit enter here, what it's going to do is it's going to use WinRM. It's going to say, I want to log in as admin. And then here's my password. And it's going to give them that hash instead of the actual password. And we'll see if it takes it. Okay, and look at that. We're in like, that was fast. So who am I? And we're administrator. So now we have full admin access. That's pretty sweet. Think of that. From the zero login, all we did was gather the hashes, right? We used zero login to say, hey, just give us these hashes of the passwords. And then we went from there and we took it ourselves and passed that hash on. So it's pretty cool because we didn't really have to do much. I mean, really, think about it. All we did was, in the grand scheme of things, we used your guys' protocol and we gave it some zeros and tried it enough times till it equaled 0, which logged us in enough to give us the passwords. And then from there, we just took the passwords and said, here's our passwords. Even though they're hashes, they're not in plain text, we passed them as if it's our password. So pass the hash attacks, while it sounds complex, you're really just acting like this is their password, which it is. It's just hashed. So some computers will take it and some won't. So now we need to read the, you can't tab apparently. So now we need to read the actual root flag, which is on their desktop. And we cat it root.txt. And there it is. Try hack me 0 logon dark 30. So keep that in mind, guys, that really all you're doing when in a pass the hash attack is you're acting as though the hash is the password. And it is the password. You just aren't unhashing it for them. You're not getting the actual password. You're just saying, hey, here it is. It would be like you getting a ticket to like a movie, right? And that ticket, they mail it to you and they put it in an envelope. And the envelope says movie ticket for so-and-so, right? And it'd be like, you might go to 10 movie theaters and say, hey, here's my ticket. And it's in the envelope. And they know what that envelope looks like. They know it. They see it every day because a lot of people probably bring it in the envelope and open it up and give them the tickets. It'd be like you go into that movie in 10 movie theaters and showing them the envelope and being like, hey, here's my tickets. How many you think would let you walk through? I bet you could get at least a couple. So that's the way I would compare pass the hash is it's just covering that password, but the computer still knows that's the password. The computer still realizes that and recognizes it. So therefore, you can take advantage of that. So hopefully you guys enjoyed this box. I love proof of concept boxes. I really do. I like them a lot. This one gives you a walk-in up top too that I don't think is as good because it doesn't explain things, but it is, if you get stuck, you can really go through there. If you want to learn a little bit more about the script, you can go through there. But yeah, I think you guys will like this one. I think it's a lot of fun, and I think it's something you guys will definitely enjoy because even though they didn't mean to, they not only teach you the 0 logon, but they also teach you pass the hash, which I think is really important. So thanks, guys. Hopefully you guys are liking it, and if you are, hit that sub button. It helps out so much. Thank you, guys.